Hi everyone, this is Fahad Mirza and I welcome you to the channel. Recently, we covered this Dia's 1.6 billion parameter TTS model, which was not only quite lightweight, but also it was able to generate highly realistic dialogue from a transcript. It was not perfect, there were some issues as we saw in this video when we got it installed locally, but I think that for the first version of a model, it was quite good. That, and you can also condition the output on audio, enabling emotion and tone control. The model can also produce non-verbal communications like coughing, laughter, clearing throat, and few others, and we also tested it out in this video. Now, for the purpose of this video, what I'm going to show you is this GitHub repo, which allows you to install this Dia's model in a Dockerized um, container that enables you to just install it with your Docker Compose and then serve it anywhere. The beauty is that you don't really have to go through the rigmarole of installing all the prerequisites, making sure that your environment is compatible, because if you can run a Docker container in an environment, it becomes quite portable, flexible, and adaptable. And that is what I am going to show you in this video. Also, another benefit which I believe it offers is that it is OpenAI's API compatible. So if you're already using some TTS model in your AI powered application, this could be a drop-in replacement. You can not only do the TTS or text to speech with this model by using this Dockerized version, but also you can create a custom voice and then you can use that custom voice in doing the TTS. It also has got multi-speaker support, and the performance looks quite good when it comes to GPU footprint, but we will get it installed and we will check out our GPU consumption. For GPU and for the VM, I am very grateful to Mast Compute who are sponsoring the video. If you are looking to rent a GPU or VM on very affordable prices, you can find the link to their website in video's description. Plus, I'm also going to give you a discount coupon code of 50% for a range of GPUs, so please do check them out. So let's get started. This is my Ubuntu system, and this is the GPU card which I was referring to, NVIDIA RTX 6000 with 48 GB of VRAM. Let me start by creating a virtual environment with Conda. And then let's git clone the repo, and I will drop the link to it in video's description. That is also done. Next up, make sure that you have Docker installed, and let me quickly show you my Docker version. So I'm using this recent version of Docker. If you don't know how to install Docker, I would highly recommend that you just search my channel. I have done a very easy to follow video on Docker. Now, in order to run it, all you need to do is to just do this docker space compose up and -d, and as soon as you run it, it will start downloading your Docker container images, and then it will run it. So and this is going to take few minutes, so let's wait, because not only it downloads and builds all the prerequisites but also the models. While it does that, let me also introduce you to the sponsors of the video, who are Camel AI. Camel is an open source community focused on building multi-agent infrastructures for finding the scaling laws, with applications in data generation, task automation, and world simulation. And it has finished downloading the model, as you can see here. It should not take any longer now. And there you go, everything is started now, which you can also check with the docker ps command, and everything is running at port 8000, and that is basically our API endpoint. Okay, so now let me show you how you can use this. So for that, I'm just going to take you here. So you see this is the API endpoint at port 8000. You can even use it in your Swagger API framework if you want to check it out. So in this first code, what I'm doing, I am just generating a speech from text, a simple way. Now we're importing these libraries. This is our API endpoint, and this is a prompt where I'm using multi-turn conversation. So this is the first one where I'm saying, "Hi, Mike, how are you doing today?" And then there is a second one responding that not bad might fair income. This is just Australian slang. And then I'm just using this payload. I'm just using this prompt here. This is a model. This is MP3. You can use Wave. The voice is Fable, but you can select any one of these. These are the headers which we need to send for our API call. We are making the API call, and then we are saving the output file here. And this is the output file which will be saved in the current working directory. So let's go here and let me, or maybe if you want to check the VRAM consumption first. So it is not even using VRAM at the moment, so which is good, all running on CPU. So let me run this TTS.py. So it is running at the moment. And now while it runs, it is now consuming the GPU. So it is using over 10 gig of VRAM, as you can see from here. And meanwhile, it has also finished generating the audio, which should be in our current working directory. So if I just go here, and this is our output file, as you can see. Let me play it.
What are you doing today?
Not bad, mate. Fair dinkum. How are things with you?
What are you doing today?
Not bad, mate. Fair dinkum. How are things with you?
Now, this might be a bit off because you see the first one, it could be due to my VM. So let me move it to my browser and then run it. And now let me play it.
Oi, mate, how are you doing today?
Not bad, mate. Fair dinkum. How are things with you?
So second one is fine. First one is still, I don't think so. It is really good enough.
Oi, mate, how are you doing today?
Not bad, mate. Fair dinkum. How are things with you?
Yeah, but tone of the second one is quite good. Anyway, I'm not going to play with the model here because we already have seen the model testing in our another video. Now, another thing which you could do is to create a new custom voice and then use that custom voice in your TTS. For that, all you need to do is to simply, I'll just go here, import the request library. Then I'm just using my own audio file with just few words in it. And then this is API endpoint. I'm using that audio file. I'm generating the new voice ID here. And once that's done, I'm calling again this API endpoint to create a new TTS in MP3 format with this text. And I'm saving it here. So let me run this. And the audio file has been created on our local system. Let me play it in the browser.
This is Fad's custom voice in action! Please subscribe to the channel, share and like the video.
I think the cloning is, it's not that good. Maybe my audio file was not good enough. There's a hint of my voice, but not really a exact clone. But that is fine. We can tinker with some of the CFG values. We can provide a more quality audio file in order to improve it. But as I said, a lot of room for improvement for this model, as we saw in our original video here. But I think for the first version, it is quite good. Other than that, this is a good tool for serving or just porting this Dia through Docker by using that GitHub repo. Check it out. As I request always, please consider subscribing to the channel. And if you're already subscribed, please like the video and share it, as it helps a lot. Thank you for watching.